I wanted to tell you about our chemistry demonstration project. We asked the big question, why do chemicals react the way they do? And the beauty of that was students, of course, got to pick their chemical, got to pick the reaction. Steve Spangler, if I can give a shout out to him, was a huge resource on this. Totally worth checking out, Steve Spangler Science. We used his work and we kind of asked that question. We layered in some inquiry about what is the reaction that's going on here? Is it physical or chemical, and why? And what does that even mean? We ripped into what are the compounds? What are the elements that are making up these chemicals that are reacting here? What's happening with those? We dug further into kind of the products and the reactants there. What are they? What's the change? Where's the change happening? What kind of bonding's going on there? So that was our chemistry demonstration project. Again, grounded in a real-life, authentic experiment. They got to troubleshoot that experiment. They got to roll through that experiment a few times and really run the scientific method. How can we do this differently? How can we do this better? How can we improve a certain aspect of this reaction? Or if we change this, does it diminish and decrease and negatively affect the reaction? So that was our chemistry demonstration project. Differently for next time, we're gonna really, I think, isolate that reaction a little more. I think we're going to really get into just those elements, those products, those reactants. What's the change? What's their composition? I think those are the key questions, so we can really get a sense of a few more elements, really get a better sense of periodic table and what it's all about. What are those groups? Can we get to know some individuals on that periodic table well enough to understand their place, why they're there, why they're not elsewhere, how there's the similarities and differences across the table, all that beautiful